I did was that after I ended the tax, after I ended my the taxes that were opened on the tax manager, the noise kind of reduced, and then I restart the computer and the noise reduced, and later it stopped. So I did some research, and they said probably the vents is blocked because I always put it on a table when I'm using it. So I had to take it out from the table and like put something to elevate it up a bit, and that stopped the noise. But when I start working again, after a while, it starts again, and then I have to restart it. So
is it a new machine?
I think I've had it for like 2 years now. But what I want to do is to check if the warranty is expired. That I've not checked though.
Okay. Did you run the hardware diagnostics on it?
No, I haven't.
You should do that, right?
Okay, I'll do that.
Yeah. Get the diagnostic tool, the manufacturer's diagnostic tool. Which kind of machine is it? Who's the
The
manufacturer?
Dell.
Okay,
Dell.
so get the Dell hardware diagnostic tool. I don't know how it's called for Dell, but just Google it. You're gonna find it and run a hardware scan and see if it detects anything, and then we
Okay.
can go from there.
Okay, thank you. But it's not making any noise now, so but I'll do that.
Yeah, and then make sure you do a system update. Did you do a system up? Did you check for updates? Make sure all your drivers are up to date.
No, I didn't
Okay,
do that.
you have all the tools to to fix your problem.
Okay, I'll do that. Thank you.
Yeah, check.
I'll check that.
Yeah, do a sys update. Check for drivers, and then run a hardware scan. And if the hardware scan cannot detect anything, if it gives you a pass on everything and the machine is updated, all
Yeah.
drivers are up to date, then that problem is gonna go away.
Okay. Thank you.
Welcome. I mean, you guys are technicians now. You should just be fixing these problems.
I was also happy I encountered it because
Yeah, it's a
at least
good
that will make
troubleshooting
me,
scenario.
yeah. So
What time are you working like all night?
yes, all night.
Oh, overnight. Oh, that's
Yeah,
tough.
overnight. Yeah. Okay, thank you.
You're welcome. Okay, somebody's trying to join. So pretty much this session is just gonna be like the same for the other sessions. Welcome, Kingsley. I see you in the back. Yeah.
Yeah, I'm right here. I'm just trying to set up. I'll be in a second.
So we'll just uh, pretty much take questions on what we've covered so far. Any concerns, anything that needs further explanation, anything that someone doesn't understand, anything that you need some more light to be shed on, or something, anything that you're not quite sure of up to this point that you feel like if I ask you a question, you're not going to be comfortable explaining. Here, now is your opportunity to have me touch on those aspects again.
Senior Gerard, definitely the OSI model. If you could like take some time to explain a little bit more, I'll be very grateful.
Okay. I think Charles didn't finish the OSI model, I believe so. So your understanding of the OSI model might not be complete, but
at least give us the juice so that we can impress him.
I'll just say some few things about the OSI model today. Let me write that down. Okay. Jonathan says OSI model. Who else? Is that it for you, Jonathan? Just OSI model?
Yes, please.
Okay. Bertrand, what is your own, tell me what you need help with. And if you cannot speak, you can just type a message in the Slack channel, in the general channel. I'm still gonna get it. Okay, no response. Jude, Jeff J, you need help with anything?
Give me a second.
Okay. Faith, anything else?
No, I'm still working on the assignment. So for now, I'm good. I use Google as my research tool and YouTube. So for
Okay,
now, I'm good. Yeah.
that's great. That's great. Okay, so let me talk about the OSI model. So I'm not gonna go in too deep because it can take us like the entire 1 hour to talk about OSI. But pretty much, OSI stands for Open Systems Interconnect, and it was a model that was developed by a group of developers and developers that work for different companies. And the whole idea of the OSI model was to have systems talk to each other, because you have a group of systems that are manufactured by different manufacturers. You have how is an Apple system going to talk to a Dell system? How is a Dell system going to talk to an HP system? How's an HP system going to talk to a Lenovo system? Because way back in the past, you couldn't use a Logitech mouse on a Dell machine, for example. You know, every manufacturer created their machine, their keyboard, their desktop, their speakers. And if you bought any other parts from some different manufacturer, it was not going to work. You couldn't use an Apple mouse on a Dell machine, and you couldn't use a Samsung keyboard on a Dell or an HP machine, and so on and so forth. So because of that, the IT world needed to come together and put together some rules that will apply across the platform, the entire IT world, that no matter what manufacturer you are, no matter what you're selling, no matter what your product is, there will be some guidelines that will be generally agreed upon, and these guidelines we're gonna be the standard for any communication that's gonna happen between two devices. And once that standard was agreed upon and adopted, it made it possible for us to freely communicate the way we are communicating today. Like, you can use any machine and any combination of keyboard, mouse, docking station, any combination you like, and you can send a message from a Windows machine to a Linux machine, and from a Windows machine back to say to a Solaris machine, and a Solaris back to Windows machine, and vice versa. these devices can intercommunicate without any restrictions because they all follow this set of rules that was agreed upon, known as the OSI model. So that is pretty what the OSI model is all about. And the OSI in itself was structured to have 7 different layers, right? So you can look at it as a set of rules or set of protocols that govern communication in the IT world. And the OSI does have 7 different layers. And take note of this, it always starts from layer 7 to layer 1, and not layer 1 to layer 7. So it goes from layer 7, 6, 5, 4, 3, 2, 1. And layer 7 is the application layer, layer 6 presentation, layer 5 session, layer 4 transport, layer 3 network, layer 2 data link, and layer 1 is the physical layer. 1 second, guys. Yes, so those are the different layers of the OSI model, and the layers must be the way they are. You cannot intermix the layers. Layer 7 will always be the application layer. Layer 6 will always be the presentation. Layer 5 will always be the session. So you cannot intermix the different layers. So for you to understand how the OSI model works, you need to memorize the different layers of the OSI model in order. You also need to know what protocols function in what layer and why. Because when you're troubleshooting something, something is not working on your laptop or on a server, you should be able to troubleshoot based on your understanding of the OSI model and be able to tell what layer that problem is coming from. If the layer is coming from a layer, if it's a layer 7 problem, you cannot be troubleshooting and looking at layer 1, right? If you are troubleshooting a layer 7 problem and you are trying to fix layer 1, then you are just wasting your time. It's not going to work. And vice versa. If it's a layer 4 problem and you are troubleshooting the physical layer, you are checking the connections while it's an IP issue, then you are wasting your time. So that's how you need to understand, like, what happens in what layer. So if you hear a problem, you can be able to pinpoint and say, okay, based on the way this problem is presented, I can tell that the problem is coming from layer 4 or layer 5. If you hear about switches, for example, you already know it's a data link layer. That's where switches are going to be in the OSI model. So you need to really read the OSI model in detail to be able to understand, like, where a problem might occur and how you might go and fix the problem. Because in IT, your troubleshooting skills got to be very strong. And the way they will test you in an interview, you cannot just be all over the place when it comes to troubleshooting. You should be able to listen to a question and know exactly where you have to start troubleshooting. And not just say, okay, start doing guesswork. I'll check this, I'll check that, I'll check this, I'll check that. No. If you start doing that, they will know you are not an IT technician, or you don't understand the OSI model, or you don't have the skills you claim to have. So understanding of your OSI model is key. So I'll indulge you guys to spend some time, read it, watch some YouTube videos on it, so you get a better understanding of the OSI model. Even if you cannot fix the problem, but you should be able to tell where the problem is coming from, what layer, based on what is going on. If I tell you there is an IP conflict happening, you cannot be checking your network cables, for example. So that is a layer 4 problem, and you are checking cables, which is the physical layer, which is a layer 1 problem. So they already know you don't know what you're doing. You don't know what you're talking about. I hope you understand what I mean, right, Jonathan?
Yes, please.
Okay. Now, like I said, communication will always start from the application layer all the way to the physical layer, and then go back from the physical layer all the way back to the application layer. So if I am sending you an email, for example, I'm going to open an email application on my machine. So I will start from, that is layer 7 right there. I type the email, right? And how do I want to present that email to you, right? Do I want to, so I open an application, let's say a text document. Before opening the text document, I have to go to my email and I have to use HTTP protocol. So all those are HTTP and all those other protocols, SSH, they are all layer 7 protocols, right? And say I use, I have to go to the internet to open my email box, right? I have to connect to the internet. So if I connect to the internet, I connect to the web, I have to use a layer 7 protocol, which is HTTP or HTTPS. I go to my email, I have to use a mail client. That is still a layer 7 protocol. So email is being controlled by SMTP, which uses port 25. We'll talk about that in detail on Saturday. 1 second, somebody is buzzing my doorbell. I will be back. So I need to migrate to another location. Okay. So where were we? Who can remind me where we were? Jonathan, where was I?
Yes, sir. You were still talking about the OSI model, and the last statement you made was you were going to talk about ports, and you did mention that you're going to dive a little bit deeper into it on Saturday.
Okay. So let's start from the application layer. I want to send you an email, Jonathan. I need to go to the web, right? I need
Yes,
to use
sir.
a web browser to go to either google.com or yahoo.com, whichever mail client I'm using. So by doing that, I'm dealing with a layer 7 protocol, which is HTTP or HTTPS, right? And I use my mail client and I open my email. For email to work, you have to use SMTP, which is a layer 7 protocol for sending and receiving emails. And SMTP uses port 25. So SMTP stands for Simple Mail Transfer Protocol. It's one of those protocols that you have to know. I'll send them to you after class. So I use my email client and I start typing the email. Maybe I decide to type the email in a text document, in a Word document, right? And I use say Microsoft Word or any other word processor. And I type that email. So all of that is happening in the application layer, layer 7. Now I'm done typing the email. What do I need to do? That email needs to be presented to you in some format. So this brings to mind when Kingsley was teaching you about file formats, dot something, dot PDF, and all the other file formats he was teaching you about and told you guys to go learn. So I will decide what kind of format I want to send that text document to you, right? So that brings in mind presentation. How am I presenting it to you? If I need to compress the email and I use some compression tool to compress it, or to compress the Word document I'm sending to you, it might be a bunch of files if it's not an email. The compression is going to still happen in the presentation layer. So I'm presenting that email to you in a compressed format. So while I'm doing that, I'm interacting with layer 6, which is a presentation layer. When the email goes to you and you decompress it, you are also dealing with it at your own layer 6 on your own side before you are able to read that email. So compression, decompression, and how the email is presented, what kind of file format, all of that happens in the presentation layer. So the email is done, I've presented it, and I'm about to email it to you. A session needs to be started, right? So we go now to the session layer. So a session is initiated between, when I click send, a session is initiated between my system and the system that is receiving the email, for example, since I'm using email as an example. So that is what the session layer is all about, beginning a session. So a session starts there. A session, take note, I'm using email as an example. It doesn't only mean the OSI model is used to send emails. So pay attention. I could still be connecting to a database server. For me to make that connection, for the connection to happen, there needs to be a session that is initiated between my system and that system. So don't just take email and feel that the OSI model is all about sending emails. I'm just using email like an example. Like I said, there is much to the OSI model. So I'm just using one example that you can understand. But my expectation is that you go read and learn more about it. And Charles is also going to break down the whole thing over the weekend. But come with questions too, so that it will make you guys understand it really well. Now, session has been initiated and my email is sent. So for that email to be sent, think of it as a mail that I'm actually posting in the post office. If I go to the post office and I address an email and I send it to Mr. Bama or Mr. Ola, for example, that email needs to be transported from the post office that I dropped it at to the post office that is nearest to you, and that post office that's nearest to you will be the one to take it to your address, right? So in the transport layer, that is what happens. So the protocols that are in charge of transportation, sorry, is TCP and UDP. Those are the transporters. That's the only thing they do. So TCP is transmission control protocol and UDP is user datagram protocol. At some point, you have to learn the difference between TCP and UDP. In the last session, while Charles was teaching, I did come in and I gave one difference between TCP and UDP. And I told you UDP is a slower protocol and it will not guarantee data delivery. I did say that. And I gave a counter argument to say UDP is a faster protocol, but UDP will not guarantee if that data will be delivered or not. For example, I think I used Emeka as an example, and I said, if I call Emeka and we get into a phone call, a phone conversation, and along the line, the phone call is breaking, the call is not going to drop because he said something and I didn't hear. It simply means a network package was dropped, right? But the call is, the session has already been initiated when he picked up the call. And UDP is already doing the transportation of the data. Some of the data is delivered, some of the data is not delivered, but it needs to be quick because we are about to communicate through, we are doing a voice communication over the phone, right? So UDP is faster, but there is no guarantee that it will deliver that data to you. It will drop some packets. But TCP is a slower protocol. However, TCP will guarantee that the message is carrying, the data packets will be delivered to their destination. And how does TCP do that? TCP does something called a three-way handshake. This is very important. I mentioned this in the last class. And what is a three-way handshake? A three-way handshake happens right before TCP delivers a network package. And what actually happens is that TCP sends a SYN signal, a synchronization signal. But if you read about it, they'll just cut it short and call it SYN signal, which stands for synchronization. So TCP will send a SYN signal to the receiving machine or the receiving system. The receiving system will send a counter SYN acknowledgement signal. And then the system that is sending again will also send an acknowledgement. So you have SYN signal, SYN acknowledgement, and then acknowledgement. So that is what is known as a three-way handshake. The SYN signal that is sent, the SYN acknowledgement, and then an acknowledgement. Once that happens, that is the handshake that happens. So once that handshake takes place, that is a confirmation that, okay, data can now be transferred because the two systems are now synchronized. And then TCP will transfer that data. And that is how you get your email and be able to read your email. But that process is a little bit slow, right? It's different from a phone call that you call somebody or you're talking to, or we're talking right now. Because for us to be able to make this phone call right now, UDP is a protocol that's been used. And that's why if the call breaks, sometimes you're having networking issues or I say something, you guys don't hear me, those are packages that are being dropped because UDP is a faster protocol, but there's no guarantee that it will deliver all the network packages that's transmitted. I hope that is understood. So that is the work of the transporters. That happens in the transport layer. So UDP, TCP, they do the transporting. After the transport layer, the next layer is the network layer. What happens in the network layer? That is where IP addressing happens, right? For that package to be delivered, it needs a destination address. So my system needs to know the IP address of the receiving system. So IP addresses and IP addressing in general happen in the network layer. And in the network layer, that's where you also have routers, where the routers will route the traffic and connecting two different LANs together based on their IPs. So if they ask you, a router, where is a router located in the OSI model? You should not sit and say you don't know. You have to know based on what I'm explaining right now and your understanding. After that layer is the data link layer. In the data link layer, that's where you have switches. They deal with something called frames. When switches send their data, when the data gets into a switch, they become what is known as frames. So in the data link layer, you see the switches, mostly switches, and how switches work, and how devices are connected using switches. All of that happens in the data link layer. And then now you have the physical layer, which is where all the connections happen, the CAT cables, the power cables that go into the wall, all of that happen at the physical layer. All the physical things that you can touch, they all happen in the physical layer. So UDP, I just saw Faith's question. Faith, I said UDP is the faster protocol, TCP is slower, and I just explained why. And so that's how data will flow from layer 7 all the way to layer 1. And then from my layer 1, it's leaving my network, right? And when it gets to your network, it's gonna get to your network through your layer 1 and go all the way to your layer 7 before you are able to open the email and read it. So that is the OSI model in a nutshell, Mr. Jonathan. Any other question?
Thank you, Senior Gerard. So what are layer 3 switches? Because I was reading and I came across like layer 3 switches.
I was about to say that too. I understand Gerard said switches are main on layer 2, but instead switches are still part of the networking layer. Layer 2 has what they call the MAC and the LLC, which are what they handle data synchronization. They still work in hand with layer 3, which is the switches, because if you don't have the data link, they will not. They don't synchronize the data. Yeah. They're there to synchronize the data from the switches or the routers. That's what I was going to add to what Gerard said.
Thank you, Kingsley.
No problem.
Thank you.
So you also have switches that will exist in layer 3, known as layer 3 switches, and you also have switches that will be in layer 2.
Yeah, because there are switches in layer 2 which are they're used for synchronization, just for synchronization. Then the ones in the networking layer, those are the ones that do the routing. They tell you the route that, okay, this is where this data is going to. After they've gotten the IP address from what destination that data is going to, that's when the switch now comes in play. And be like, okay, yes, this person is going this direction. Let me send this person on this switch link, because the port has already been configured that all the data that's coming from this IP address to this IP address is going through this port. That's how it's been configured, just to keep a traffic, the flow of traffic without having what they call it, network traffic. You don't want to have like I'm just trying to find the term to put it. Yes.
Data collision.
Thank you.
Because switches are very smart. Without switches, the network, there'll be a lot of collision in the network, right? Before switches, they had something called hops. Hops were very...
Yeah, hops were the arcade.
Hops were very unsmart or very stupid. Let me call them that way. They always say, what is the difference between a hop and a switch? And some definitions that I've come across is a hop is a dumb switch, while a switch is a smart hop.
Yeah, the simple one is just that a switch is the faster hop. Just put it that way.
Yeah, it's smart. Besides being fast, it's smart because you cannot configure a hop, but you can actually configure a switch. A switch got an interface, and if a switches got tables in them, for example, if a switch routes traffic from my network to Jules' network, it's gonna store that route in a database in the switch. So that next time, if Jude is sending me an email, the switch will already know because it's taken that route before, right? So you will know it's coming from Jude, it's going to Gerard. It's just going to take it. But a hub is not going to know. A hub is just going to send something called a broadcast. Like it will send a broadcast message like, you know, the way they used to do radio broadcasts way back, right? And you need to put the antenna out. And if
Radio
the antenna
frequencies.
picks the broadcast, good for you. If the antenna doesn't pick it, okay, fine, right? But they don't do that anymore. They don't do broadcasts because broadcasts will lead to data collision. So imagine a hop is sending a broadcast out and a receiving system is also sending data out. It's also sending a broadcast. Data will collide in the network. But a switch is intelligent enough to know that, okay, I will take this route to deliver data to this person. This other person, I'll use this other route. You know, so it has a route table within the switch.
And another thing too about the switch that they configured, they came out with a switch was because why? For security too. Because if somebody is sending a secure data to a specific person, you don't want to do a broadcast, because when you do a broadcast, any person can receive that data and just get the information. So they made a switch in a way that it sends data just to a specific person, just for security reason. Because if I'm sending a data to Gerard, I want that data to go just to Gerard, not everybody in the class. That's why we have the general, if you look in Slack, we have the general category, and then we have personal information that we can send information to anybody. That's just like a switch. But the general part is just like a broadcast. Because if I'm broadcasting an information to everybody in the class, I go to the general location, I put it in there so everybody can see it. But if I want to send a specific message to Gerard, I go under Gerard's name. So right now, what I'm doing is that I'm picking a specific person to send this information to. That is exactly what a switch does. So it picks a specific destination, send the information to just for security reasons, because it doesn't want everybody to get that information. So that's pretty much like, that's what happened behind a switch. If you guys want to go deeper into a switch, I mean, that's a whole another course for like a year or two. Because configuring a switch, that's a whole full-time job just to configure a switch. They not even go into routers. Routers is even the worst.
Yeah, if to learn how to really be effective at configuring routers, you have to take network switching and routing. So
right.
They call it CCNA.
Cisco certified. I think Cisco certified networking.
Yeah, Cisco CCNA routing and switching. That's another course if you want to go deep into networking. You know, so courses like that, I just took them just to boost my networking skills, not because I wanted to be a network engineer or anything.
Right.
I mean, networking doesn't pay that much, so I wouldn't want to waste my time.
And it's a whole lot of stress.
Yes, but
because
understanding networking is key to your survival as an IT personnel or an IT professional. Yeah, but some people just enjoy networking and they make networking their career.
Right.
You know? But in this course, we need to understand networking to be able to be comfortable with our Linux, be comfortable with our AWS when we do start AWS. Even the Windows that we are doing next week, after next week, Kingsley will take you into installing Active Directory,
we're gonna go to Active Directory
and doing some networking stuff, you know, and setting static IP, static host names, and all that.
You gotta set a host name, a static host name, IP, setting static IP address to your server, and then using that server as a domain controller.
Exactly.
That's another important thing you guys gotta know. If you guys want to start getting it, just go do a research on it. You can read through. So I mean, I'm expecting a lot of questions that day. So you guys just start preparing yourself.
Yeah. So any other question? So Jonathan, I hope my explanation has kind of helped a little bit.
Yes, sir. It's perfect.
Is it still you want me to keep going, or is it still complicated for you?
No, sir. It's fine for now. Thank you.
Okay.
Anyone else has any doubt or facing any difficulty somewhere else along the line? Because that's why we have this Wednesday.
I just want to point something on the homework. There's one part of the homework that says run a hardware diagnostic test on your machine, use the snipping tool and send us the result. And I see people doing a whole host of different things. I don't understand why. You know,
Yeah.
someone run a file system check. I didn't ask for file system check. You know, that's like checking for corrupted file systems. That's not what I'm asking for.
Yeah,
You
I
remember
even have a question about that.
in class, I used Kingsley showed you guys an example, and I also showed you guys an example. And I used the hardware diagnostic tool on my machine. I use Lenovo. So the hardware diagnostic tool that is offered by my manufacturer, Lenovo, is Lenovo Vantage.
And
And I
another thing,
used that and I performed a hardware diagnostic, and I was able to show you guys the results. So use the hardware diagnostic tool that comes with your system. If you don't know what it is, Google based
Google it.
on
Yeah.
what kind of machine you have, and they'll tell you, use that, run the hardware test on your machine, and send us the results.
Yeah, so Senior Gerard, Senior Kingsley, I
Yes.
tried looking for it online, but
What machine do you
I
have?
use HP.
You have an HP?
Yes, please.
So if you want,
what I
it's very, 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 very easy. If
okay,
you cannot,
sir.
if you cannot find it, go to hp.com.
Okay, sir. Okay,
If you want, we can do a share right now. I can show you the one for HP just to make you understand a very an example.
yes,
Gerald, can you
please.
give me a permission? Let me.
If no one has any other questions, yeah, I'll welcome that help.
Yes, go ahead.
All right, give me a second. Let me share my screen so you guys can see. I'll show you exactly again. You have to give me a moment. I think it's telling me I cannot share yet. You have to make me co-host.
You are.
Oh, okay. Who can share? It says only host. That means you have to make me host instead. Make me host. I can. It's
You're the
telling.
co-host. Maybe it's because you signed up with 2 accounts and then you dropped one. I don't know. So I made you co-host of the account that I'm seeing here. So you're the co-host right now.
I don't have the other one. I dropped off the other one, so I still use the same one.
Okay. So
Yeah.
let me.
Just make it host. I'll give you host back when I'm done.
Make host. Yeah. Yes. Go ahead.
All right.
Is it working?
No, it's giving me. It's a share screen. Oh, okay. That's fine now. Where were we? Right here. All right. As you were saying, so if you go to hp.com, right there, it's gonna bring you to the HP site. You can go under support. You see where it says support? You can get software and it gives a support and troubleshooting. You have here, you see diagnostic tool. Can you see them?
Yes, sir. Yes, sir. Please.
So if you click on diagnostic tool, it's gonna bring you to where your diagnostic is. If this is a direct HP machine, it's gonna take you directly to the diagnostic. But you see how it gives you options? It says HP printer solutions. It gives you printer, it gives you computer issues. You can go under computer issues. Wireless, Bluetooth, whichever one you want to do diagnostics for. You can do sound diagnostics, you can do full system diagnostics. It says display and touch screen, perform a system recovery, no. Windows operating system issue, no. Wireless, battery, power, no. Keyboard. But you can always go, it's always going to give you a where you can find the full system. If you cannot see it, you can always search in the web, in the site. So it says computer diagnostics, Windows 10 support, printer and scanner. It gives you all the options here, right here. So it's not really something that's difficult. This is just the HP one. For Dell, I can do Dell. If I don't have a Dell software on my computer, I can go to Dell, the same thing. Go under support. If it's not under support, it has to be, let me see, product solution. Let's see, services. If I cannot find it, I just go up here and search. Sometimes you search, it doesn't come out the right way, but it will give you like you see, it shows you right here. Even if I didn't type the correct one, but it's gonna give me the right one. It says, okay, run a hardware diagnostic on your Power S server. It tells you like all what you want to do.
Exactly. If you're at work and they ask you to run a diagnostics on a server, that is what you will use. If it's
That's exactly what, yeah. Right here, if it's a Dell server, Power S server, you run, because this is what my company use right now. This is a server that we'll use at my company. We have like about 2 of them right now in where I work. But if you want to run that for servers, if you want to just run just a regular system like your PC, it's gonna be this one. But I know the one for Dell because why? My company uses Dell. So if you want to find for Dell software, it's called Dell Command Update. Right there. And you can download it on a Dell machine. Once you download this application, it stores on a Dell machine. Each time you want to run diagnostics, you just go click on that Dell Command Update. It runs all diagnostics and install any driver that is new on that computer. And it's going to show you all the drivers that needs to be installed first before you even go ahead. It tells you the ones that are critical, the ones that are recommended, the ones that are urgent. It shows you all those classifications. You now can select like, okay, I want just the ones that are urgent and the ones that are critical. You can just, you can always take out the ones that are just like, recommended. It doesn't mean that you necessarily need to install those ones. And same goes to Lenovo. You can go to lenovo.com and it's going to give you the same thing too. It's going to go to the site. It has its own diagnostic tool. Tool.
It's called the Vantage, Lenovo Vantage.
Yep. See, PC tablet. I know. I'm just trying to go through the website itself.
Yeah.
Yeah. So if you go to like the website itself, you can always search there. If not, you can just do if you know it, you can just do the Lenovo Vantage. So Lenovo Vantage services. Let's do that. And you can always download that and save it on the Lenovo machine. It's always going to do a run diagnostics for you. Like right now, I'm using the download itself background. No, let's see, support Lenovo. So this one is just giving me a description. So if I want to download it right now, since I'm using a Lenovo laptop, I can download it. It's going to just ask me to sign up. You sign up as well, get it going. But I already have it on my machine because mine came with the machine since it was a corporate machine. We already have it on it already, so I don't need to download it anymore. But if you want to download on your machine, you can always just sign in, put in all the information, and it downloads from Microsoft. That's exactly how you run a diagnostics. And once you have it there, if you want to know you have it on your machine, you can just go here, you type the Lenovo right here on your search bar. It's going to give you. If it's not there, it's going to tell you that you don't have it on the machine. You need to download and install it on your machine so you can run the diagnostics. Or if you don't want to install it on the machine, you can technically go to the browser and search it from there.
Hey,
and install it.
I have a question, Kingsley.
Yes, sir.
Hey, could you clarify for Dell? If I wanted to download the diagnostic, which one would I use? If you go to Dell Command, like you were showing us,
you do Dell Command Update.
Yeah, if you go on that website, they have 2 on there.
All right, hold on. Let me
figure out which one do I go. They have one for Windows because I have Windows Pro, so I'm not sure if I should use the first one because I have 2 different updates.
All right, hold on. Let me see. You did Dell.com, right?
I did Dell Command Update. That's what I Googled.
So you did Dell Command Update.
Yeah.
Another way you can search, you can just always go here too. I believe you can go to the website itself and search it from there. Let's see product or software. So I can do Dell Command Update.
So it says it has 2. There are 2 downloads available for Dell Command Update.
So you see, can you see my screen?
Yes.
So you see it has 2 of them right here. Either or is gonna work. You see how it tells you here?
Click on Dell Command Update. Click on the first one. Let me see.
This one, right? No, I don't even need to click on it. It tells you, this is where it gives you the information up here. You see how the information tells you? It tells you from Windows 10. That means this one is an older version. They just came out with a newer version. That's what I'm trying to say. Like,
No,
this,
dude, what are you looking at? I'm looking at two different things. I'm looking at the actual website, and it shows the release date is January 2021.
right there. It's right there.
Yeah, okay, that's what I'm asking.
That
Which
is what I
one
was showing you.
Which one I do? Would I do the Windows 32 and 64 bits, or
64. You do 64 bits.
but it's because it's two different. There's one that says
No,
universal.
Emeka, it depends on your machine. Is your machine a 64-bit or a 32-bit?
The one that I would suggest you to do it is a universal platform. You see the first one?
The first
that
one,
says,
okay.
The one that says universal platform, that's the one you want to go.
Okay, because the reason I'm asking, they both have 32 bits and 64 bits. Right? Yeah, so
There's, hold
hold
on a second. Let me see something. It says Windows 32 or 64 bit for version for Microsoft Windows 7 all the way to 10. But this one is a universal one. That means it can work in both Windows 10 and a newer version, because you know that they're about to come out with Windows 11. Have you guys heard that?
Nah, man.
Yeah, it's along the line. I've seen just a preview of it. I don't know if that's real, or we're still hoping to see if it comes out. But this is a newer version. If you want to do, you can just do the like, you can download the most newer one. Some people are still with the 4.0, which is the 2021. But we're already here, because when I try to do a Dell command update for my company, like any Dell command update we already have on our machine, it tells me that there's an update already for this one, and it updates to the newer one automatically without even me doing it. So you probably want to use this one, the Universal Window Platform one, because the reason why they put this Universal one is that your system might be a 32-bit or 64, that you don't know how to figure it out. But if it's a tech person like you can figure it out which system, which one your system is running on, if it's a 64-bit or a 32. And do you guys know how to do that? Does anybody know how to figure out if the system is 32 or 64-bit?
I showed the class how to do that, so I'll be surprised if they don't remember.
Does anyone know how to do it? Let me stop sharing my screen so I can probably give a chance for somebody to answer the question. If not, then I'll pick somebody.
The question again, please.
Do you know how to figure out if your system is a 32-bit or a 64-bit?
My is 64 bits.
System.
Oh, sorry. I went to settings.
Mm-hmm.
I went to settings.
Mm-hmm.
And when I went to settings, and about.
Yes.
And it shows me, say your PC is monitored and protected devices. It shows me the specifications, the device.
Right. There's so many ways you can. There's so many ways you can get to that information, and we've shown you guys all the several ways, faster ways, shorter ways, and longer ways to get to it. Another way is that you can just go to your File Explorer, click on right-click on this PC, go to Properties. It's going to show you everything. Another way, you can just type system information. It's going to give you all your system information, tell you what system you're running on, how many bit in. Another way you can do is your desktop. You can just right-click on your desktop, go I think it's display settings. I think under display settings, it should no, not display settings. Yeah, you can still go under display settings. Then now you search. That's a longer way to go. That's not a longer way to go, but
yeah, that route is longer, but it's still gonna bring you to.
It's still gonna bring you there.
File to your hard drive, and then you're still gonna select properties and things like that. It's gonna bring you to this PC. So I think the shorter way will just to go through system information or File Explorer.
Right. So that's how you can tell your system is a 64-bit, for you to find out to know which one to install on your system. Emeka, you're there, right? So you know which one now. You know which one now to pick.
I have a 64-bit.
So now you know which one now to pick.
Yes, sir.
All right, that's great. Anyone else having any question somewhere? Mr. Bismarck is not with us today.
This might probably busy.
Mr. Bismarck. Jude, do you have any question, Mr. Jude?
Not yet.
You don't have any? All right. How about Miss?
So
How about you, Miss Faith? Bama, you have any question?
No, for now.
Okay.
Yeah.
I mean, but if anybody has anything about like the homework, is you're all free and welcome to bring it on the table right now, so we can give you a clue about it, but we're not gonna give you everything. I can
Yeah,
give you a little
so I
piece of the
have
pie. Go ahead.
about the homework. Just trying to wrap my head around like the sequence in terms of like trying to get some information from the web.
Okay.
See? So like, I don't know if the sequence makes sense. Like for instance, if we're trying to type, let's say facebook.com. So my chain of thought is what I'm trying to communicate to see if it makes any sense. So as soon as, let's say you type like facebook.com from your web browser, so it goes, I'm just talking about just the sequence. So it goes to the DNS server or the local DNS on the router.
What is the question? What is the question from the homework?
So yeah, it's good that Jonathan brought that question up, because the answers I've been reading, people have been answering that question with like 3 or 4 lines. I'm like, no. That question is deep.
Long, yeah.
It's deep. I expect people to write a long. I expect to read at least half a page for that. You know.
Yeah.
I see people answering the question with 4 lines. So Kingsley, the question is, you should explain what happens when you go to a web browser and type, say for example, www.facebook.com. Explain what happens until the time the Facebook page loads for you to sign into the Facebook website.
Oh, okay.
Explain what happens in the background.
So what's the process before you get that Facebook and Facebook and my page?
Yeah, before the page loads.
Okay.
Yeah.
So far, Mr. Jonathan, what have you gotten from like that from the answer?
Yeah. So what I'm thinking is like as soon as you type in the www.facebook.com, so let's say from your PC. So let's say the local DNS server, which is the one that has been configured with your router, would change the domain name into like an IP address.
You got it. Just you're right. You're on the right path, but I just want to correct you something, because just to make you guys understand, we got to start using terminologies, since we've been trying to teach you guys about terminologies, IT terminologies. So during that process, you're not gonna say it's gonna try to convert or whatever. It's not converting. It's querying. They call it querying.
Querying. Okay, sir.
It queries when you type that information, it queries the DNS server. Okay. And when in the meaning of that querying means that it's not like you arguing with somebody. That's not it. What it does is that it takes that information that you put in, it brings it to the DNS server. The DNS server now convert that is called host name. That name that you're written there, facebook.com, that name is called a host name.
Okay.
So when you queries that host name, it goes to the DNS server. Now it converts it, it changes it now, it queries it to an IP address. Okay, so by you saying changing, you can say query. It queries it to an IP address.
Yes, sir.
So the thing is,
yeah,
to understand it better, right? So Jonathan, you can just say DNS is gonna query the DNS database. DNS actually has, so all this information that we're talking about, DNS actually keeps it in a database.
Correct.
And if you went through the IT terminology document that I shared with you like a couple or 2 weeks ago, one of the terminologies there is SQL, structural query language, which I said is a universal language which is used to query databases, right? So DNS actually has a database, right? And for that information to be gotten out of that database, it needs to run a query. And what are you actually querying in the DNS database is something called records. So when DNS keeps storing this information, IP to hostname, IP to hostname, hostname to IP, they become known as DNS records.
The A record. It's
and you
called the
have
A
different
record.
types of DNS records. You have an A record. If you convert a host name to an IP address, that is an A record. If you convert an IP address
to a host name.
back to a host name, is known as reverse lookup, otherwise known as pointer record.
Yep.
You know, the reverse, right? There is also a CNAME record. There's also MX record for mail exchange record.
Right.
Mail exchange. So there are different forms of DNS record. So DNS does
Right.
not only keep one record. It depends on what
Yeah.
you're actually querying. But in this case, since you are doing an IP, a host name to IP lookup, that is an A record. So what you should be saying is that DNS will query its A record.
Yep.
The A record in the DNS database and get
Simple as
the IP.
that.
So Jonathan.
Yes, sir.
Reverse and shoot again.
Back up a little now and come again. Let's hear it this time.
So when you type in www.facebook.com, so your IP address is going to query the A record on.
The IP will query the A record?
No, I'm sorry. Your computer, right? Will
your computer?
Your host device.
Okay.
That you are typing.
The router.
The router? No. There is something
No.
missing there. How can your device query the A record?
No, your web browser.
Okay. All right.
Yeah.
Thank you.
That's what we're going to.
The web browser is going to query the A record on the DNS server to find out the domain name, the corresponding IP address or will query the corresponding IP address. Then from there, please hold on. Yeah, so from then the queried IP address goes through the NATs, right?
Okay, Jonathan, pause right there. What if the web browser queries that DNS server and it doesn't find that record? What happens?
Yeah, so if it queries that and doesn't find that record, it's escalated through the it escalated through the NAT, then it goes.
So wait, right now, which DNS server are we looking at? Which
the router?
Query?
The router.
At home?
Yeah, your local, your LAN. Okay. Yeah.
All right. So it's gonna escalate it to where?
It's gonna escalate it to your ISP.
Okay. What if it doesn't find it there?
Then the ISP is also going to escalate it to, let's say, another DNS server. So let's say maybe.
And which other DNS server? How is it called?
An external DNSP server.
How is it called? That's why I gave out this homework, so you guys go and look for this information. So I'm trying to pull the information out of you by force right now. Good shot. Just continue. I'll correct you. I'll point you to the right direction, but just complete your answer.
Yes, please. Yeah. So if it goes through the NAT, then the NAT, with the help of the default gateway, will carry that data package using your public IP address of the router and make a query to the DNS server for the Facebook.
Are you sure? You already have the IP. Why are you querying Facebook's DNS server?
Oh, okay, yeah. So that was where I was confused. So which means, okay, so once like it queries it and
You are looking for the
finds,
IP. It's like you are looking for a key to a certain door. You already have that key. Why are you
oh,
going to
okay.
ask the key again?
Yeah, so that was where I was confused, sir. So once it finds, like, let's say, it queries the A, so what, the A record, and find out that you have it in your local DNS server, then it brings the information back to the web browser. Then you're able to launch like your Facebook.
Okay, so let me just, I'm not going to explain it in details. I'll just give you highlights. And then
Yes,
my
please.
expectation is that everybody in class takes what I'm saying and you go do more research to it and answer the question the right way in your homework, right? So when you type facebook.com on your web browser, what happens? The first thing that will happen is that your web browser will check your local web browser cache. If you've ever gone to facebook.com, if you've ever visited facebook.com, then it's going to be cached in there, right in your web browser. So all this process that you're explaining will not happen if facebook.com is cached on your server. So your web browser does something called caching. So caching means once you visit a website, any website you visit, your web browser will cache it. It will just keep that information. It's like its own database known as cache. So that if you need to visit that website again, you don't need to go through DNS and all that. You just go to that cache and get the information from there. And it's going to point to your web browser where facebook.com is because it's already a cache. It's in cache and it has the right IP. So suppose and this is how you answer the question in an interview. You don't just say it goes to cache and then gets the IP from there and then contacts the Facebook server and the page gets saved. That is it. No. You answer it systematically. It checks cache. If it is there, this is what will happen. If it's not in cache, this is what will happen, right? So I've already told you what will happen if it is cached. If it's not in cache, the next thing, it will check now your router, the DNS server that is in your router, and it will query that DNS database. That DNS database is a record. And if facebook.com is there, then it will get the IP from there, right? And resolve it. You resolve the host name from there and serve your web browser that IP to make a connection with the Facebook server. If it is not in your router's DNS, then it will be sent to your ISP's DNS server.
Sure.
Right? So Bismarck, please don't interrupt. Let me finish. So it's gonna go to your ISP's DNS server, and the same process will happen. It will query the DNS database of an ISP if it has Facebook.com. If it doesn't have Facebook.com, your ISP will escalate it to what is called root domain, which is out of your ISP. So you will go now to the root domain. It's like a root DNS server, root domain. And when I talk about root domain, I'm talking about the .coms, so a root DNS domain server will hold something like .com, .edu,
.net, .org.
.net, .org, all those popular dots that you know will be in the root domain, the root DNS server. If it is not there, it will be escalated again to some other DNS server known as I think the first level domain, something like that, right? And the same procedure will happen there. It will query the database from there. If it is not there, it gets escalated again to the next level domain server until it reaches the top level domain. When it reaches the top level domain, it must find it there. If it's not there, then you will not be able to reach that website. But if it finds a record in the top level domain, which in most cases is not going to reach the top level domain. But the reason why you're explaining this thing is to let the interviewer know that you actually know this thing. You are displaying knowledge. It's not like you're just trying to dodge the question, right? So you explain all the way to the top level domain. And if it queries the top level domain and gets it there, it serves that ISP to your web browser. Your web browser takes that ISP and makes a connection with the Facebook server using the Facebook, using the IP address that it just got from that DNS server, that top level DNS server. And when your web browser connects with that with that Facebook server, what happens? I just spoke to you about TCP and UDP. So in a situation like that, which protocol will be used, TCP or UDP? Because for the Facebook page to be served to you, a three-way handshake needs to happen. So which protocol will be used?
TCP.
Yes. So your web browser initiates that connection with the Facebook server, and he's saying, okay, I need you to serve me the Facebook web page. Okay, the server is like, okay, begin the three-way handshake. So your own system, which is now represented by a web browser, sends the SYN signal. The server responds with the acknowledgement SYN, with the SYN acknowledgement, and then gets now again the corresponding SYN signal. And then now that handshake now has happened. It means the two IPs are talking to each other. The two systems are talking to each other. The Facebook server is now talking to your system. And that is where the Facebook server now will now serve that web page to your web browser for you to be able to log into facebook.com. That is what I expect in that homework. If your answer is not within these lines, then you are off track. So Jonathan, did I make sense?
Yes, sir. Yes, sir. Thank you.
And you now see where in the process how three-way handshake came in, and you can now relate it now to some level at the OSI model, right? So all of these things are interconnected. You have to know what is happening where. Yeah, I think we are already above time, but Bismarck, I think you were about to ask something. You can do it now.
Concerning, hello.
And please, anything any question, please try to keep it within the scope of what we are discussing. You know, don't take us like way out of what we are talking about right now.
Yeah,
take people off track. So we are discussing networking. So keep it networking.
Yeah, sir. It was relating to when they add. Hello.
I can hear you.
Yes,
Go
we
ahead.
can hear you.
Okay, thank you. You said that when the Facebook address is typed in the browser, if that person or if that user has never visited Facebook, then the browser will search. But if the user had visited Facebook, it means that the Facebook is found in the cache, in the browser cache of that user.
Browser cache, yeah.
In the browser cache of that user. The question I'm asked, the next step, one step that I was able to see that I did not get understanding was, what is the role of operating system? Because some people say that the browser also checks if it doesn't see it if the browser doesn't see it inside the cache, it goes to the OS cache before. If it doesn't see it again in the OS cache, it moves to the router before it goes now to the router cache. If it doesn't still see it,
so it's just like you can go ahead and mention that there is also an OS cache. So cache is just like a place where information is stored. right? Your web browser
Temporary.
can it's just like memory, just like cache, like something like memory, right? So your OS does have cache. So if it doesn't see it in the web browser, it can also check the OS cache, right? But if you don't want to mention the, OS cache, that is still fine. You are still on the right track and you are answering the question wonderfully. You know, so it is not a must that it will check OS cache. If it doesn't see it in the browser cache, it can check OS cache. If it's there, it will save it. If it doesn't check OS cache, it will check straight to your local router. You know, so that is an additional step, but it's not a mandatory step. But you can still add it just to expatiate your answer. It's still good. I love the research you're doing.
So I wish that you still explain that three-way handshake just for 1 second, please. It's little bit to get the real sense out of it. It's not very easy. I tell you.
Okay, so a three-way handshake is a process that occurs prior to two systems exchanging information over the network, where the system that is requesting information, let's say a client system is trying to connect to a server to request for some kind of web page or information. So the client system will start the three-way handshake by sending a synchronization signal or a sync signal to the server. The server will receive the sync signal and respond with an acknowledgement sync signal. It's like acknowledging that, yes, I've received your sync signal, right? So the server will respond with a sync acknowledgement. And when the server responds with a sync acknowledgement, then the client will also respond with a sync signal again to say, okay, yes. Sorry, the client will also respond with an acknowledgement that, okay, I acknowledge that you've sent me the sync acknowledgement. So that process that happens is known as the three-way handshake. If a three-way handshake does not happen, then the data will not be exchanged between the connection between the server and the client will not happen. So after the three-way handshake happens, then the two systems will synchronize. And when they synchronize, then data exchange can take place. And that's how the web server will be able to serve you web pages.
Okay,
So
thank you very much.
read more about three-way handshakes. It's very common.
If that three-way handshake is not established, that's when you get a 404 error message on your web browser.
That's when, you start seeing 404 error messages and you're like, what is going on?
And those are some things those are some of the error messages that you should see it, and just from the beginning, you can easily resolve it without even doing a research on that error message. When you see a 404 error code, it knows that you're not getting connection from whatever server you're trying to reach or whatever destination you're trying to get information for. You should just know that either that server is down, or you don't get connection, or your system is not connected to that server, or maybe that server has have an issue that's not sending out information and it's not getting internet access. That's where you're getting a 404.
Okay, sir. Hello.
Yes, we can hear you. Go ahead.
Oh, thank you. That one is clear. I've understood it very well. The next issue now is at the level of that OSI. This communication. Now we are talking about. I'm seeing server handles HTTP requests. Which of the server is it? The web server or the I don't know.
Okay, Bismarck, the example I gave you in the homework was that you are contacting, you're trying to reach facebook.com, right?
Yes.
So that already tells you that you are trying to make a communication with the Facebook server, which is over the web. And if the Facebook server is over the web, then you are dealing with the web server. And that's why we are talking about 404 errors, which are HTTP errors.
Okay.
All right, guys, it's almost 8:30. It's which I know in the East Coast is like 9:30 right now. So
Yep.
we'll be wrapping up. Any question we'll take right now? If there is no question, then please let's call it a day. Thanks for coming to this brief session, and I hope you guys.
And I hope just sorry not to
Mark,
cut you.
it seems you always you are not keeping track of the time. 8 p.m. Eastern time is 7 p.m. Texas time. You always come 1 hour late.
I was 1 hour late waiting, thinking that people have not begun.
Yeah, look at the message each time a message is put out. 8 p.m. EST, that is Eastern time, that's East Coast time. You are in Texas, your time is CST, Central time.
Yes.
Okay.
So which means they are 1 hour ahead of us. So their 8 p.m. is going to be our 7 p.m. It's just like on Saturday for us in Central time, Texas time, class is going to start at 9 p.m. But for people who are in the East Coast like Kingsley,
yes, with 10 p.m. With 10 p.m. 10
sorry,
a.m. in the
10
morning.
a.m. It's going to be 10 a.m. for them. But for us, it's going to be 9 a.m. So you have to know your time zone and correspond to the message that is being sent out.
Yeah, that's
And I hope everyone did see the message I sent out on Slack regarding the homework has been extended. I just want to make sure everybody did see it.
Yes.
Okay.
Yes.
Yes, sir. Thank you very much.
Sir,
no worries. Go ahead.
Initially, I thought that loopback address was just a particular IP address called 127.0.0.1, but I'm seeing some other schools of thought saying that loopback address can extend from 127.0.0.0 right up to another range which has around about 250 something. So I did not know why they changed loopback address, which was 127, and put it in a big range.
Loopback address will never change.
It will never change.
Yes, it's always going to be 127.
127.0.0.1 is the loopback address. We're not talking about the range. It can be there could be other ranges that are used to troubleshoot the IP stack, right? But 127.0.0.1, and I showed you the IP classes that starts from 0 to 126, and 127 was left out. And I said, why do you think 127 was left out? In the IP classes, if you go do a referral on that document, you will see, and I asked that question in class. It goes from 0 to 126, and then starts from 128. And then I asked what happened to 127. And then I told you guys 127 is reserved for the loopback. You know, loopback could have a range, but it will always be 127. But 127.0.0.1 is the loopback address that is used to troubleshoot the IP stack. And it will never change.
All right.
Yes.
Okay, sir. I troubleshoot my system with 127 with ping. Ping 127.0.0.1. And later on, after using the sniping, the tool to copy and paste it, I realized later on that my system is the IP address changed from the IPv4 to the IPv6. What really could have happened?
I think Kingsley showed you. Go to your NIC. You take care of that problem. You can,
okay.
Because if you go to if you check your NIC, you see that both IPv4 and IPv6 are enabled. Jonathan was facing similar problem in the last class where his NIC was displaying just his IPv6, and we had to go disable it and allow just IPv4. So you should do the same thing. Go to your NIC, disable IPv6, enable IPv4, so you get just an IPv4 address all the time.
Okay.
Because if you don't do that, the addresses can interchange if both are enabled in your NIC. Good question. Hi, guys. I think we can all say goodbye for today, and we'll see you guys on Saturday.
Thank you so much.
All right, guys. Thanks for coming, and I hope you guys had fun.
Thank you very much. Have a good night.
Enjoy the rest of your week, guys.
Thank you.